Assalamu alaikum. My name is Tahouri Tahar, and I'm assistant professor at the Faculty of Technology at Martlige University in Lakwat, of course, Algeria. I'm a member of the Renewable Energy Development Lab and its application in the Sara area, Bashar University. So today I'm going to talk to you about deposition of CZTS thin films by successive ionic layer absorption and reaction SILAR method for photovoltaic application. But I think that the most interesting question to answer is not what I do or what we do, but is why. Why we do it. Why we choose the photovoltaic solar cell. Why the SILAR method, deposition method. Why the CZTS thin films? What the importance? So the outline of my talk after the introduction, we try to answer the question why we choose the photovoltaic solar cell, why the SILAR deposition method, why the CZTS thin films, and then we try to present our different experimental results, and finally we come to the conclusion. So in the beginning, we can see in this photo the electricity demand outlook in selected region or countries in the stated polarized scenario between 2019 and 2013, global electricity demand recover and to space pre-COVID-19 level in 2021. Electricity demand growth in India outpaces other regions to 2030, after which growth is most pronounced in Southeast Asia and Africa, nearly 40%. So for this reason, going solar has been a sustainable and a sharper solution for dozens of countries. So we can see also the small cubic in the global annual energy consumption in the world resource, of course, the nature, and the big yellow cubic shows that the annual solar energy radiation to the Earth. That means if we compare between the volume of the big and the small cubic, we can see there is 1,000, you can imagine 1,000 times difference between them. So what does it mean? That means we can utilize just 1% from the solar energy to replace all the other resources. So for the answer to the question of why the photovoltaic solar cell, first let me explain to you the meaning of the word photovoltaic. Photo, that means the light, but the voltaic is the unity of electric potential. Further, there is many advantages of the photovoltaic solar cell. The most important is sustainable and environmentally friendly, economical and easy to maintain, good and good for remote area, and the most importantly is cheaper cost and high efficiency. So now to answer the question of why the CZTS thin films. There is many material with high efficiency like cadmium telluride, 22.1% efficiency, or CGIS with 22.6% efficiency. But this material, it's very expensive and not available in the nature, toxic or harmful to the environment. For this reason, many researchers focus on low cost and eco-friendly material with high efficiency, like CZTS. In addition to this, the CZTS thin films have another absorption or another advantage, like high absorption coefficient, suitable optical bond, between 1 and 1.5 electron volt, environmental friendly or no toxic, and chemical abundance. Now, why we choose the SILAR method? Historically, in 1984, Ristov and his group were the first to report this method, but Nicolau and his co-worker named it in the same year. There is many reasons why we choose this method. The first, it's an inexpensive method, simple, versatile. The thin films can be deposited on a large area onto any type of substrate. A relatively short time process and report time. The good ground rate of the film by changing the deposition cycle and the concentration of the precursor solution. Many properties of these films can be easily controlled. So the figure shows the cycle of this process consists of 4 steps. The first, or in the first figure, the absorption we choose, we show the absorption reaction. In the second, the first rinsing, and the third, the reaction, and finally the second rinsing. So in the present work, CZTS nanoparticles were synthesized by the SILAR method, and their structural, compositional, and morphological properties are analyzed. The XRD analysis confirm the formation of CZTS with crystallite structure, and the average crystallized size is found to be 29.06 nanometer in the peak 1112. So the calculated lattice constant and A and C of the film for tetragonal structure are calculated, and it's very close to the result in other publication. So for the same result, you can see the sharp of the homogeneous layer of the CZTS thin film. Sorry. So figure 3 summarizes the effect of the position solution volume of the absorbance and the band gap by considering both the absorbance and the transmittance. The band gap energy value are found to be 1.43 and 1.48 electron volt for CZTS 30 and CZTS 14 sample, respectively. Sure. So the direct band of the CZTS thin films generate is estimated to be 1.51 electron volt with an appropriate solution volume of deposition around 50 milliliters, which is the optimal band gap for visible light absorption and get close to the typical value reported in the literature. So finally, in the conclusion, we successfully deposit the CZTS thin films with the SILAR deposition method, and we get a satisfactory result, which characteristic structure with acceptable value of lattice constant and a band gap of 1.51 electron volt, the good absorption in the visible zone. This result can be improved by changing many effects, which temperature reaction during time, self-annealing, post annealing treatment, and partial process S and SE. And finally, thank you so much for giving me a chance to present my research.